Hello, everyone. Welcome. My name is Meha. I am part of the CISO AppSec team at Citi, and I'm also a co-maintainer of OWASP dependency track. I've been in the software industry for almost 10 years now. I got introduced to this project around 2 years back when I joined Citi, and have been contributing since then. Yeah. Citi as an organization takes great pride that we are not only taking from open source, but also contributing back to the community, and lets us as developers do that with full freedom as well. Saiba, do you want to continue?
Thank you, Meha. I'm thrilled to see you here for our talk. My name is Sahiba. I'm from India. I've been living in Ireland for over 5 years now, and I have around total 7 years of experience in software development. I joined Citi 2 years ago as DevSecOps engineer. Unlike the traditional software development practice being followed in industries, in Citi I was introduced to the concept of open source contribution. Believe me, I didn't know about it before. I find it way more fun because you don't get to follow steps by the book, and you learn as you go. Like in our team, we think as end users, we brainstorm as analysts, and then we develop and deploy as engineers. I've been working on the dependency track for last 2 years now. And outside work, I'm a chess lover, and I love reading astrophysics. Today, we're going to walk through our baby project, Hyades, which came out of the dependency track. And now I'll hand it over to Meha.
Thanks, Saiba. Who all, before starting all this, has any one of you heard about dependency track before? Tried using it anywhere? Did you feel like that's really good actually. And did you feel like it doesn't scale well for your organization level usage? No? Okay, so that's actually good. But yeah, today's talk is firstly about the contemporary space, what is happening today and how it is affecting our work in open source security. Then just a recap on dependency track, what it is, how it functions, the legacy application, I would call it. And for those who don't know it, you'll get to know about it. Then we'll walk through OWASP dependency track Hyades, that is the scaled version of dependency track. The primary focus being that for enterprise level scale, where we have like hundreds of thousands of projects to be scanned, we needed a single portfolio to manage everything. And that led to the foundation of Hyades. Then we have some demos for you today that will just emphasize it again, how useful this can be as part of your open source security toolset. So looking at the contemporary space, the biggest deal today is that like hackers can embed malicious packages in your software supply chain, and that malicious package can be sitting as much as like 15 levels down in your dependency tree of your application, and you may or may not be aware of its existence as well. And this kind of package is not really detected by the current security tools by themselves. So here I have an interesting stat from the Sonatype's 9th annual State of Software Supply Chain report, which says that there were 245,000 malicious packages detected in 2023, which is the double of what it was in 2019 to 2022 combined. So you can imagine how much it has increased and how much we need to pay attention in this domain. Another thing is that like it's not just vulnerabilities that we should be worried about. There are sometimes stale components in your application which are there, and we don't care about it unless on one Friday there is some vulnerability in that also, and you just don't know what to do about it because there is no support available for it. So being capable of detecting those kind of packages and getting away from them is also one thing to be careful about. So just as a summary, like a lack of awareness of what components are there in your application, what components have become stale, which ones are vulnerable, which ones are malicious in this case, all of that is just leading to an increase in the attack surface of your application. And in our team, we say, it's a saying for us and for everybody, I think, stay current or die. And in this case, we just want to be current in the knowledge of what application we are deploying or using in our environment, right? So, okay. And with the introduction of the, so with the introduction of the executive order, we all are aware that bill of materials or software bill of materials can give us a picture of what is happening or what is the composition of our application. And yesterday I heard multiple talks about SBOM also, so I will assume that you guys are kind of aware. If not, I can take more questions outside. So talking about bill of materials again, we all are aware that it will help us, but just having a bill of materials for your application or any application, and what do we do with that information? Like, just having that doesn't guarantee you that you are secure from open source security perspective, right? So this is where we need a platform which will be able to digest that SBOM, give you, or any bill of materials for that matter, and give you information about the vulnerabilities, outdated components, malicious components. And there is policies that we want to apply at the organization level, license violations we might be wanting to check. All of that is needed, and this is where dependency track comes into picture. So talking about the OWASP dependency track application. This was founded by or created by Steve Springett in 2013. And he also received the SANS Award for 2023 as the best open source application creator. We like to call it as a high velocity bill of materials processing platform. What it does is it will take the bill of materials as its input, and it is highly configurable, so it allows you to configure the sources from which vulnerability information is being mirrored. So yeah, we do allow mirroring from NVD, OSV, etc. And then the vulnerability analysis itself, what sources will be used for that. So there is multiple sources you can configure there, like Sneak, and OSS index. And then you can apply policies, licenses, and other information on top of that. There is also repository meta-analysis, we call it, whereby you can get meta information about your components. So it is like the published date of your packages, whether or not the package is old. You at least want to be aware of that. And then malicious packages also. And all of that can be sent down as notifications via webhooks, Teams, Slack, etc. And there is also integration with other applications like ThreatFix and Kena Security with that. So yeah, that's a highly functional platform, and you guys already, some of you have tried using it, so you would be aware how much power it can give you. But along with that, we have some limitations that came for us when we tried to adopt it for our organization specifically, if I call it. So first thing is scaling to 100,000 projects, for example. That was not possible with the legacy application or this current application. We call it vanilla dependency track in our team. And the other thing is With this kind of application, you can have real power if you are able to incorporate it in your deployment pipelines, right? So, for example, just before you deploy your application, the bill of materials that was generated at build time can be fed into dependency track, and you can get the current state of your application in real time and be sure that whatever you were trying to deploy is actually the same thing you are deploying now, and the vulnerabilities and everything else is up to the mark for the current deployment. So for being able to be used at that scale, you want dependency track to be highly available. And that was not possible in the current architecture because as a small limitation here, it did not allow active deployments or multiple instances of the same application. So these two small limitations for us led to the foundation of Hyades in our team, and Saiba will continue explanation of that next.
Thank you, Meha. Now you know how TT helps with the SBOM operationalization. I'll go to the next slide. You might be wondering why Hyades was created, why we have created this new project. So as Meha explained, DT is used to manage the projects and its vulnerabilities. But when it comes to large industries, they might need to ingest tens of thousands of projects and enormous number of SBOMs for analyzing. And then they might face the limitation of this monolithic API server. This motivated us to extract few of the services out of dependency track into the Hyades service to make it highly available active deployments in the CI/CD environment. And first of all, what does Hyades word mean? It is a Greek word which symbolizes the cluster of stars in a constellation, and we have chosen to reflect the same, the cluster of services which Hyades can handle. You see, it's a very high-level view architecture of our new project. On the left-hand side, this is the existing API server, and on the right-hand side here, we have the scalable separate services which have been separated out of the API server. The bridge between the two is built using the Apache Kafka. So if you see the flow diagram here, whenever an SBOM is ingested in the API server, the components are sent as messages on the Kafka topics, which are being listened by these separate services. For example, vulnerability analyzer here, it will fetch the vulnerabilities for those components from the third-party sources like Snake, OSS Index, etc. At the same time, the repo meta-analyzer, it will fetch metadata of the components from the respective repositories based on their package URLs. API server also doesn't have to worry about sending notifications now. It is being handled by the publisher. We also have one more service to mirror the list of vulnerabilities from the data sources like NVD and OSV. So all of these services are now being handled by Hyades, and API server doesn't have to worry about it. All of these services are scalable, and they can be scaled up or down to multiple instances. And if needed, they can also be deployed as self-contained native binaries, offering a lower resource footprint. Hyades, you can call it a superset of dependency track, and we keep it updated with the upstream parent project by backporting the new release changes. I would also like to give a thanks to the DT open source community for their growing contribution so far, and I can assure you we'll keep adding more stars to our constellation. This is a very high-level view. If you want to know more about it in the technical details, you can always go to our GitHub page by scanning this barcode here. Okay, enough with the theory. Now we'll go to the demos. Apart from the DT functionalities, we have developed many new features in Hyades, but due to time limitations, we're going to walk through only 3 of them here. First of all, what is integrity analysis? Integrity analysis tells you about the integrity of the component. If your component is verified or not, how it is done, It is done by comparing the hashes of your component, which you have uploaded in your project, by comparing the hashes from the reliable repositories. For example, okay, so here I have integrity project. In the components, each component has the metadata, which has the hashes value, these hashes value. Now I have repositories here. So like for Maven, I've already configured the Maven Central. So whenever a Maven component is uploaded in the project, it will fetch the metadata from this repository and will match those hashes with your component and will let you know if your component is verified or not. If I go back to my project here, sorry. Yes. So I have many Maven components being uploaded here, and under the integrity column, you can see I have green ticks which shows me that my component is verified. It gives me the metadata that the hashes match, when it was last fetched, and where it was fetched from. And if the hashes don't match, or if the hashes are missing, somehow, if it doesn't verify the integrity of the component, it will show me the icon sign here. So this is how the integrity is verified. Okay. The second one is one of our favorites, a cell-based policy evaluation. First of all, if you have already used dependency track, you must be aware about the policy management. Dependency track gives you capability of creating policies. And in the policies, you can use the list of these predefined conditions to track the policy violations of your project. But it can get a bit messier when the conditions get bigger. It can be difficult to maintain and read all those conditions. So to tackle that, we have created this cell policy. Cell stands for the Common Expression Language, and it provides you the syntax code editor similar to the C-style languages like Java or JavaScript. And if I try to edit here, it will show me the syntax error if there is any. I find it very fancy. You can also add as many conditions as you want here. These macros, like compare age, matches range, these are being used as the policy conditions. Like compare age will tell me, will violate this policy if my component is more than 6 years old. Because components may have the latest version available, but they can still be 20, 30 years old. And I want to know about that component if it's being used in my project. So like here, I've created this cell policy, and I'm using these 3 macros, compare age, Perl matching, and matches range. Any Perl matching all of these 3 conditions will violate the policy. I'll show you how. Like in my projects, cell project, I have uploaded a component whose Perl matches, the range also matches, and this is more than 6 years old. And if I go to my project, under policy violation, there is a policy violated here. If I expand the policy violation, it will show me which conditions were broken. And this is how you can manage the policy violation easily using the cell policies. Cool. The last one is the global vulnerabilities policies, and I would like to ask Meha to take it from here. Thank you.
Thanks, Saiba. So to start with this, actually, how many of you are aware of VEX documents? Great. So with that document, the thing that we can achieve is given an SBOM. If you have that vulnerability exploitability exchange document from the vendor, saying that a particular vulnerability in a project is not affecting them, you can use that in DT or in dependency track to update the vulnerability being shown you. So for example, you can suppress a vulnerability based on the vendor telling you that it is not affected. So an example document I had, just for those who are not aware of it or just want a recap here. This is one example VEX document that is saying for dependency track application, I'm saying that my vulnerability with this CVE is actually not affecting the project because of code not being reachable and a workaround available. So given this kind of document, in dependency track, you can go to your application or project, and in the audit vulnerabilities, you can apply the VEX, that document that I showed just now as an example. So when we talk about an organization, there can be policies which we want to enforce based on our organization's decisions also. And those policies would be across the portfolio, right? And in the beginning, I said this project can now scale to 100,000 projects. And we have actually tested it with 60,000 projects so far in a prod-like environment. So given those many projects, you won't be interested in going with a VEX document around all of those projects and trying to manually do your suppression or whatever action you want to take based on the organization's policy, right? So for that reason, we have come up with the global vulnerability policies, as we like to call it. For that, we use something called policy bundles, which present in an external server, which would be, dependency track would be polling at regular intervals that can be configured. So for ours, it is, right now in this demo, it is configured to 40th minute of every hour. It will be syncing with an external policy in bundle server. The ones that we support are Nginx and S3, and today I have an Nginx server running in the background. So given that server, and we just zip up some policy files that, okay, please take this action if a particular vulnerability is present across any project in my portfolio. And that once the bundle is seen by DT and pulled in, the same action, whatever has been specified, will be taken. So how it looks like, I have two examples for today. I hope you can see it. Is it, should I zoom? No? Better? Yeah. So I'll also move this out. Okay. So this is how the document looks like. The name type is there, and then description. One interesting thing you can do with it is on what period that policy is applicable. So here I have like a valid from and valid until on the document, and DT will make sure that, you know, beyond this, outside the boundaries of this period, this policy is not applied. So if it was applied earlier, it will be removed, that the impact of it will be removed. And the most interesting part of it is the conditions section, where again we have used the cell expressions, if like we say it. So common expression language, giving us the greatest amount of flexibility that we can get with the properties of projects, vulnerabilities, and components. So with this cell expression, I'm able to access almost all the properties of these three things and use it for creating a policy. So here, I'm saying that a project's tag might, if it includes public facing in the tags, and the vulnerability ID is this particular ID, or the alias of it has this ID, the same ID, and component's name should be commons JX path, and that component is introduced in your project as a dependency of another component, which is of group Spring Framework Cloud. So you can see, like, we are now also able to access the dependency graph of the entire application and point to very specific components in the tree. And then I'm saying in the analysis action that, okay, if this vulnerability is present, I'll be saying that it is not affecting me, and because of whatever reason I want to specify in the justification of that. A second example I have, and we'll see how it acts when I upload the policy bundle, is this one, and I'll just quickly go through the condition section here. So the vulnerability ID, like we saw before, in this case I'm also matching on the component's package URL, saying that the package URL should be of that similar to that expression over there. So looking for snake YAML here. And the version range of snake YAML I'm specifying to be anything less than 2.0. And the dependency, the component or snake YAML should be introduced by another component whose name starts with spring hyphen some regex. You are free to provide any regular expression here. And the version range of that component, like the Spring Cloud component introducing it, that version also you can monitor it to be something. So here I have put greater than 2.6.0. And again, there is an analysis section which specifies what is the action that is going to be done when this policy is applied. So coming back to dependency track itself, here in the policies section, the vulnerability policies are right here. They have already been synced because of the schedule I talked about. But there is a manual resync available, which is right here, so you can sync the policies back in. And if we look into what is actually brought in by DT is the same thing. I'm sorry, I can zoom more. This is the same thing what we saw on my files just now. So the first one is the Commons JX path one with the same analysis what we specified in the document. And the second one is the snake YAML policy, which, I hope you trust me on this. It's the same policy. So those two are here now. Now seeing what it actually can do, like how it is automated for us in DT now, the policy application. I have an example project which says test with tag, and I have this public facing tag is present on this project. And now if I go and I'll just upload a bill of materials here. So all the components are in, and if we look at vulnerabilities now, there are 30 vulnerabilities found here. Just zooming in a little bit so it is visible now. And if I have this show suppressed findings is on, so currently suppressed findings are here. We can see there are two suppressed findings. One is the snake YAML one, and the other one is the Commons JX path. Okay. Yeah, I'll just hurry up. So let's look at this one itself. Right here, we have the same policy which was uploaded has been violated, right? And getting into the dependency graph itself, so we can see that the is dependency of was actually taken into account. We are saying the group of the component introducing it should be Spring Framework Cloud. And if we go inside the dependency graph of this, Commons JX path is here, and going left, right here we have, just zooming in a little bit. So org Spring Framework Cloud is the group of the component that introduced my particular component in question. So this is how flexible we can be with vulnerability policies. And just going back, completing this thing now. Call to action. Here are some interesting links if you guys want, like the presentation today and want to check it out a little more. Trying it locally, you can use this QR code. We have multiple issues already there in our GitHub page. You can. Yeah.
You can zoom in.
Good. Okay, thank you. Yeah. Sorry, just forgot to do that in a hurry. So yeah, that's that. And interested to contribute, we are going GA with this application soon. And the path to GA is also there as an issue on GitHub. You can take a look, check out that one as well. Our own LinkedIn profiles, both of us, and I would also like to thank all the open source contributors who have participated in Hyades. Special thanks to Vinod Anandan, Nicholas Duster, and Vitika Shukla as well. Yep. Thanks.
Thank you.